Hey guys, so this is for Unit 1, Section 2.6, Example 3. Example 3 read, a rectangle has one corner on the graph of y equals 25 minus x squared, another corner at the origin, the third corner on the positive y-axis, and the fourth on the positive x-axis. So what makes sense most to me, let's sketch this out. Okay, so you have a rectangle. One corner on the graph of 25 minus x squared. That's an upside down parabola. So if you want to write this way, this is how you do it. That means you go up 25 because that's where the y-intercept is. So here's 25, make a graph. Your x-intercept would be 5 because x-intercepts when y equals to 0. So if I go 5 this way, negative 5. So this is your sketch of a parabola, okay? Then it said you have a rectangle. One, it's on this curve. Well, what did I do? There you go. One, that's one vertex. Another one at the origin. The third on the positive y-axis because the rectangle, this has to line up with where you plot the first dot. And the last one on the positive x. And again, same thing, because the rectangle, this has to line up. So this rectangle, you can make however size you want. I mean, technically, I can make this size, right? Technically, I can make different color. Here we go. Technically, I can make like skinny this way. So it's really a personal choice. But right now, let's make that blue one since I already make that the prettiest, okay? So there's a blue one. We drew that out. Part A, express the area, let's call it A, of the rectangle as a function of x. So x here, it's the base. So x is your base. We don't know how big that is because we just randomly graph that out. So that is x, and this is then y. So this point right here is x comma y, because we don't know how high it is, and we don't know how wide it is of the base. So area is, here we go, area, it's going to be length times width, which is really x times y, but it only wants in terms of function of the x. So area in terms of x is, well, x will stay. Well, what on earth is y? Well, congratulations. Y is this. Y is 25 minus x squared. So all I have to do is substitute y with 22 minus x squared. And from here, we can distribute. So area in terms of x is 25x minus x to the third, and we box that up. That is the area formula in terms of your x. Would I also accept non-distribution form? Of course I would. You can even box that up. Question B, what is the domain of A? And again, the domain is talking about what value can x be? In this case, it's talking about what values can the base of this rectangle be? Obviously, x is the base. The smallest base you can have is anything slightly bigger than 0, non-inclusive 0. Well, what's the largest value you can have? Well, the largest base I can make, it has to be no more than 5, so non-inclusive 5. Why 5? Well, the reason it has to be 5 because this parabola, it's outside of this rectangle, aka this rectangle is inscribed inside of this parabola. So it cannot go any further than the x-intercept. Graph your area formula. Okay, let's find decimals. So let's find decimals if it's still around. Let's see. All right, here we go. Here's my decimal, slowly coming up. X that out, and what I want to enter is x. Let's see. We want to enter 25, I'm sorry. Well, I guess I can technically do x to the third first, or negative x to the third first. Dude, come on, get it together, right? Okay. Negative x to the third, or 25x first. Well, 25x, let's do that first. Subtract x to the third. Perfect. Now let's zoom in the applicable portion of your graph. Not everything is applicable. Now, what do I mean by that? This is a graph. As you can see, it's a cubic, so it's going to look like a cubic, but it's an application. X represents the base, so you can't have anything negative on this graph. So you want to zoom in for the X, anything that's bigger than 0. Well, in addition to zooming that in, let me make this darker for you, okay? Projector mode, there you go. And I want to make sure the scaling, we don't want any negative here, so we'll start at 0. And we don't need that much because let's do 5. Okay, perfect. So this is pretty much all I'm going to focus on, this area. Well, that's the graph. Let's go and sketch that out. A parabola. Even though the entire function is a cubic, but the applicable part, and you only need to sketch the applicable piece when it comes to an application. So X represents the base, Y represents the area, and based on our little sketch, the max you can go is 5, and then 1, like that, okay? For what value of X is the area the largest? So now you can use your calculator or decimals. If you are using your calculator, I will help you find the maximum in your calculator, on your graphing calculator. So let's find the large, oh, I didn't mean to pinch it in, I mean zoom it in. I just want to find the largest area. All right, there we go. So based on this, as you can see, it is 2.887, 48.113. We will take this back and we'll write that in our answer or notes. Now, when you get a point from your calculator or your decimals, make sure you know what it stands for. So we saw a point of 2.887, 48.113. This is X, this is Y coordinate, but Y in our application is talking about the largest area. So how do we want to write this out? We want to write the largest area, even though it didn't ask for it, but most likely I will ask on the test. The largest area is 48.113. We did not get the unit of measurement before, so we just use square, unit square, when X is 2.887 units. And box that up, we'll highlight that over. Okay. And that's how you solve the largest area type of questions. Once you have the equation, you can use your graphing calculator. In the graphing calculator, you want to do zoom and zoom fit, and then do second calc and then the maximum. Now, if you use decimals, that's also okay as well for your homework. On the test, though, I do expect you to use your calculator. And this is the end of our example 3.